membrane, also known as the plasma membrane. I heard you guys define it oh so very well while I was watering plants in the greenhouse, but I will tell you the modern accepted description of the current cell membrane is the fluid mosaic model. We call it the fluid mosaic model. With your partner, take 33 seconds to discuss what you think fluid mosaic model means. What does the mosaic part of fluid mosaic stand for?
Picture, like made of smaller things in the big, it makes one big thing.
Can you think of some examples?
Like Finding Nemo, when those fish.
That's not the example I wanted.
That was good. That was good.
It's a bunch of small pieces that form to make a bigger picture.
You guys should be accustomed to seeing a couple of mosaics on a fairly regular basis. The low altars at Divine Child are mosaics, right? Who are on those mosaics? Who is it?
Joseph.
Joseph's one of them.
Mary.
Blessed Mother is the other. Now here's the thing about those mosaics. If they were made of all of the same pieces, would either one be Mary or Joseph? So there has to be some subtle differences in the pieces that it gets made out of.
Yes.
And those differences help it serve its function. Now where you're like, those things have functions? Well, of course they do. Art has the function primarily of beauty, which is why modern art is not art. It has the function of beauty. And it also has the function of drawing one to prayer. It couldn't accomplish those functions without different pieces. So here, there must be different pieces that make up our great big picture that aid in the function. Now, fluid, the hard part. What does fluid mean in this context? One brave, two brave volunteers. Two brave volunteers. Rock, paper, scissors for it. That would entertain me thoroughly. Yeah.
AJ was.
Wait, are we going 2 out of 3?
No,
I
you
only
got it.
did 1 round.
Yeah.
That's good. Are you answering?
Yes.
Excellent. So what's fluid mean? So most of the time we hear fluid and we think liquid. But the cell membrane's not made out of liquid. Here instead, I want you to think of the word fluid as
Is it flexible?
flexible, like a dancer's movement. When we call a ballerina fluid, we don't mean that that dancer is a bucket of water. We do mean to describe their movements as flexible, graceful, continuous. So fluid here is not a noun, but rather an adjective. Tells us a lot about the cell membrane. Tells us a lot about how it performs its function when we understand it that way. A lot of small pieces that are flexible. Now you guys are about to be with some rules. There's got to be rules in this hour. You guys are about to be a piece of the mosaic. And the first piece that I'm going to tell you about is the piece that you're going to imitate. You are going to be a phospholipid. Do you remember phospholipids from that October chapter?
It look like a, what is it called?
It's like a hydrophobic Yeah.
Saber.
Wait.
Can I? That's the dark side. You can do. You know you can do 2 at a time.
Oh, I can do 3 at a time.
Oh.
What am I saying?
What explain everything.
Yeah, you can switch. You do 10 at a time, like both hands. Fingers.
Cannot. That is against
No.
the
Like, can you do one at a time?
Yeah.
No, that's fake.
I'm pretty sure it's illegal to do
Please no.
that.
No.
Oh.
You max out at 3. So,
Should replayer only.
a phospholipid is this one individual piece right here with a glycerol head. Do you remember glycerol? Glycerol. And 2 fatty acid tails. One fatty acid tail, the second fatty acid tail. There is a reason for that. They have to be shaped just like that. One of those fatty acids is saturated, and the other fatty acid tail is unsaturated. That makes a huge difference in membrane function. A difference that is best illustrated by using each of you as a glycerol. As we look at these, our glycerol with our two fatty acid tails, you just demonstrated exactly why, chemically, and for all life on Earth to exist as it does, for organisms to do what they do inside of their cells, why it's so important that one is saturated and one is unsaturated.
Wait, the saturated one's the best one.
The unsaturated one is better. If both were saturated, the glycerols would pack so tightly together, nothing could enter or exit the cell. There would be nothing that could pass. But if both were unsaturated, anything could pass. It'd be a free-for-all. Anything could go in or out at will. That's bad for the purposes of trying to maintain an internal environment in a cell that's stable. So one being saturated and one being unsaturated allows the membrane to have a very specific membrane density that allows some stuff through, but others not. That phenomenon has a very special name. It makes the membrane semi-permeable. What does semi mean? Half, part, sorta, in the middle. Permeable. Able to be permeated. Yeah, things can pass through it. So some things can pass through it. Here's another moment to discuss with your partner. Think of real-life examples of things that are semi-permeable. Good ones. I heard some excited ones. A screen door.
Would a ball that like can soak water count? Like it gets heavy when you put water in it and you squeeze it and the water comes out?
Absorbs water, but like if you put it with something else, like marbles, it's not going to absorb marbles.
Yeah.
Sure. Skin?
Like a strainer.
A strainer?
That's what I was gonna say.
Colander? Sieve? Any of those, right?
Miss Winfield, I was wondering if we had any papers from our class.
Papers. Have I handed you papers? No,
No?
no papers. But the video is on Plus Portal.
Oh my god!
Hi, you. Hi, you. Hi. Hi. Sieve. Cheesecloth.
Yeah.
It's the cloth that you strain cheese with. So when you make cheese, well, when you make cheese from liquid, you have to separate the curds from the whey. You put it into. You're looking at me like this is like make cheese.
I didn't even know you could make
Yeah, absolutely. So if you're doing that process, you require cheesecloth because it separates the curds in the whey, and it allows you to squeeze together the cheese into a shape. Try making some mozzarella. That'll be one of your assignments over the course of the next few weeks. Make some mozzarella. Also, make some bread upon which you can put the mozzarella, and we call it pizza.
And then you eat the pizza.
I'm really fussy about my pizza, so I make my own. It's the only pizza I eat. It's the stuff I make.
Wait. Oh yeah, you explained that.
Yeah, I know.
Wait, why?
I still think
I don't know this one.
I told my mom to go there, but I forgot what it's called.
Celery $8.49.
Wait, what happened?
So I don't eat pizza because I hate tomatoes.
Wait, so when you have BLTs, you don't put a tomato on?
I just don't have BLTs.
Do you like
Well, the tomato seems like an important component of a
I don't put
BLT.
BLTs, and I don't put tomato on my BLTs.
Yeah, nice of all
Yeah.
BLTs. Yeah.
I don't like lettuce or tomatoes, so I forgot what it is.
It's a BL.
Same.
I love lettuce.
Huh.
You just eat lettuce plain.
Um,
she loves
I like
lettuce.
spinach kale.
Hey, but while we're thinking about it, since I'm already having you make your own pizza, because I told you to make the mozzarella, because you use cheesecloth, another strainer that you would use in the process of making your own pizza would be if you're processing your own tomato sauce. Those of you who have the tomato mill at home, the food mill, that you separate out the seeds from the tomato actual paste itself, there's another semi-permeable thing. Semi-permeability, the concept of it always kind of reminds me of one of my favorite semi-permeable things was the screen, because we do things to those screens to make them semi-permeable to other things. Those other things usually being our pets. We take a screen door and we put like a dog door in it, right? Suddenly, it keeps out all of the undesired things, bugs and stuff, but it allows our dogs or cats to pass freely through the door, in or out, at their choosing. My sister's house has one of those. This fluid mosaic has many parts, like any mosaic, but those parts are not all identical. Every part that gets embedded into the membrane is embedded with a function. And sometimes they're like this. The function is to be a larger passageway for items that need to either enter or exit the cell. But they're of a specific shape. So stars only go through stars, and moons only go through moons. Are the chemicals really star and moon shaped? Of course not. But they all have a specific shape that they allow only one thing through, which is how the membrane retains its semi-permeable integrity. Now you do need this picture, so I'm going to pause again momentarily for you to make sure you get this picture somehow. One to do because you already understand that the membrane can't settle too close to itself and it can't dissolve too far apart or it loses its integrity. Cholesterol. I fear that will never get old. I only fear it for you. I'm quite content doing it. Cholesterol embeds itself neatly in between those phospholipids. And I am going to increase the level of penance you are doing by making you think about something you cannot have.
Why?
Bacon. It's Friday.
Oh, that was kind of mean.
Penance.
A lot of us are like, it's okay, we don't like bacon.
So, let's think about bacon. And bacon, the white strip on bacon is fat, right?
Yeah.
What happens when you heat that?
It turns into a liquid.
Turns into a liquid. And when you remove the bacon from the pan and you allow the pan to cool, what happens to the fat in the pan?
Solid. It gets solid.
Becomes solid again.
We're just talking about this in health.
Cell membranes are made of fat, right? We call them phospholipids. So when a cell membrane gets too cold, it becomes solid and it loses that fluidity. When it gets too hot, it behaves just like that bacon fat. It's going to move too much and becomes a liquid, and then you don't have a membrane anymore. So the body, any organism, has to have a way around that. The way they prevent that from happening is by embedding cholesterol into the membrane. Cholesterol prevents the phospholipids from settling too close to each other, but it also prevents them from spreading too far apart. So it stabilizes the membrane to temperature changes. It's really, really important. So it serves a pretty important job, which is why I always feel bad that cholesterol somehow gets a bad name. People are like, oh, cholesterol, that's bad for you. Not all cholesterol is bad for you. It is absolutely essential for your cells. Without cholesterol, there is no way your cells could have a functioning cell membrane. So don't shy away from all cholesterol. You may, in fact, eat eggs. See, eggs, you can have egg salad when you go home. You can have eggs. Just can't have bacon.
So if there was no cell membrane in the cells because of no cholesterol, what would happen to the cells?
There would be no cell. Because that establishes the inside and the outside, right? Mm-hmm. Without a thing that establishes inside or outside.
Everything would just be, so let's say someone didn't eat cholesterol at all, what happened to their body?
People who have a diet too low in cholesterol tend to have drier skin, injure more easily. Cholesterol is really, really important. Add to the fact that cholesterol is the basis of all of our hormones. So then you don't have any of the hormonal changes that are associated with humans. So super important. Unfortunately, it's eating too much of it and of the bad kind that it ends up in your bloodstream rather than in your cells. And that's the kind that causes heart disease. So we don't want that either. But don't like shy away from it and treat it as an evil. It's absolutely essential. It does a really important job here. That's about all the information I'm going to get in your ears today.